Hello, welcome to class. We're ready to work on finishing up that lesson we were doing yesterday on rational exponents. Remember, rational exponents are just fraction exponents. This is still section 5-7, and we're just going to move right along here. If you recall, this, even though it doesn't look like a fractional exponent, really is. It is a fractional exponent because anytime you have a root, it actually gives you a denominator to have as part of your exponent. Okay, now, if I tried to take the fourth root of 4 here, it doesn't work. We'd have a decimal. If I tried to take the fourth root of n squared, once again, doesn't work. So in this case, we're also not going to be able to find like bases because we have 4, then you have n, so this is something different. However, what we can do is look to see if we can find like exponents. So we check to see if you can find like exponents. And here's what we mean by that. I want to write this number using exponents. 4 is really 2 squared. So just like in that example from yesterday, it almost feels like you're going backwards, but you're going backwards so that you can discover something. Now, since these are the same exponents, that means you can write it as 2 squared times n squared, or you can combine these, put them in parentheses, and use 1 squared between them, like this. So this is really 2n squared. Alright, now since we have the same exponent, this is now in the same format where we can change it into a fraction. Okay, our fractional exponent will be numerator 2, denominator 4. Now, hopefully it has been ingrained in you that you would never leave a 2/4. 2/4 would always be reduced. So the 2/4 would turn into a... Okay, you better all have said or thought 1/2. Okay, so now the 2/4 has been reduced to 1/2. And you can either leave it like that or you can write it in its root form. Here's the root form. Square root of 2n. So that this is now completely simplified. Alright. So all kinds of things to keep your eye out for when you're looking to simplify these expressions. Okay, once you get the hang of it, the things that aren't quite simplified just begin to look not quite right to you. They begin to look ugly. Okay, so our final answer here is the square root of 2n. We need to look at another one. Okay, there's a whole bunch of different things to look at, and your job is going to be able to look at them and then figure out what to do about them. Now, yesterday we were working on denominators. One of the things we were doing was working on when you had a radical in the denominator. So I want to show you one that not only has a radical in the denominator, it's got a fraction exponent in the denominator, which you can't have. But that fraction isn't by itself. So it's not going to be enough to say how many more do I need to get 1. because if I multiplied it by that, then I multiply you distribute, you'd end up with this one also times that extra thing, and you'd end up with a radical in the denominator again. You wouldn't have gotten anywhere. So it will break down into finding some form of 1 to multiply by. Let's take a look. I can write it in my other form. Seems somewhat helpful. However, we're not there yet. But if you can recall from earlier in the week, we talked about conjugates. Okay, we talked about conjugates. This has a conjugate. And when you multiply something by its conjugate, you will always get rid of the roots. Okay, so we need to think and remember, what is the conjugate of this denominator? We don't care about the numerator. We need the conjugate of the denominator. And if you remember, the conjugate of square root of a minus 1 is, let's see, conjugate of the square root of a minus 1 is the square root of a plus 1. Okay, we're going to use this conjugate. We're going to use this square root of a plus 1. Okay, this is not the answer. I know I circled it, but it's not the answer. This is just part of it. We have to use this. We're going to multiply this thing times the conjugate over itself. Okay, we're going to multiply this by this conjugate over itself. It's going to be a very strange looking 1. Okay, but here it is. There's your very strange looking 1. This is the conjugate of square root of a minus 1. Square root of a plus 1. Square root of a plus 1. Now, the advantage to the conjugate, like I said, you will always get rid of your roots this way. Now what we need to do is we need to multiply out the numerator, and we need to multiply out the denominator in order to simplify it. Okay, so let's begin to do that. The numerator is actually a two-part expression times a two-part expression, so we're going to have to use something that's like FOIL. We need to multiply using a FOIL-like method, first, outer, inner, last. You need to multiply this a times both of these, and then this 1 times both of these. Then you multiply this square root of a times both of these, and this negative 1 times both of these. Alright, so let's do that. In the numerator, we get the square root of a times the square root of a. Plus 1 times the square root of a. Now, many of you will be simplifying as you go, but I don't want anybody to miss where these are coming from. Plus 1 times the square root of a. Plus 1. And the denominator is going to be square root of a times the square root of a plus 1 times the square root of a minus 1 times the square root of a minus 1. Now we have some cleaning up to do in this thing. Okay, the square root of a times the square root of a is square root of a squared. 1 and 1 is 2 square root of a plus 1 over the square root of a squared plus 1 minus 1. It drops out. Minus 1. We have to do one more simplifying step here. Okay, so the other simplifying step is you need to turn the square root of a squared into just a plain a. So we have a plus 2 square root of a plus 1 all over a minus 1. Okay, and this is the answer. Okay, so once again, square root of a squared gives you a plus 2a plus 1. Notice this no longer has a square root, no longer has a fraction in the denominator, so it's good. This is simplified. Okay, this is simplified. Alright, now this last one is just this with less steps. I need a little bit better. Now, you might say, well, wait a minute. How do I know if I've actually gotten my answer finally simplified? Well, we have a list of criteria for that. The expression is simplified when, number 1, it has no negative exponents. Number 2, it has no fractional exponents in the denominator. Number 3, it is not a complex fraction. So in other words, you don't have a fraction over a fraction. And the index is the least number possible. So in other words, the index, the fraction exponent got reduced. So the index is the smallest number possible. So let's all write that down. An expression is simplified when it has no negative exponents, it has no fractional exponents, in the denominator, okay, so this also covers radicals, because remember, a radical is nothing more than a fractional exponent. It is not a complex fraction. In other words, no fraction over a fraction. And the index of any remaining radical is the least number possible. Okay, so what we should do is we should just take a look quickly at some of these previous things that we did. So an expression is simplified when it has no negative exponents. So let's take a look at the first 3 examples we did. Okay, first of all, it has no negative exponents. Alright, well, in these I see no negative exponents. So that's the first thing that you look for. Okay, so check. It has no fractional exponents in the denominator. Now you're not going to write all this down right now, but I really want you to look up, pay attention. So I'm checking for fractional exponents in the denominator. Let's go back up to this one that you did. Nope, I'm seeing no denominators at all. Okay, this denominator is an exponent denominator. We're talking about a denominator of a fraction. Okay, so it passes that one. It is not a complex fraction. Well, those, like we said, weren't fractions at all. And the index is the least number possible. Alright, well, let's check these out here. Number 5. Is the index the least number possible? Yep, the index is the least number possible. Even if I rewrote this as 2 to the 3rd, okay, we could possibly put it in another form. We could possibly put this one as 4th root 2 to the 3rd power, which would be 2 to the 3/4 power if we wanted to write it in another form. But still, either way, the index is still 4. So we really wouldn't even have to do that. So we did actually achieve our goal on that problem. Okay. This one, undefined, so we couldn't really do anything with that. Let's look at another one and evaluate it based on those criteria to make sure that we have simplified it completely. Okay, slide 10. Okay, well, slide 10 is just a fraction 1/2. Okay, our answer once we simplified that was 1/2. So let's think through the fraction 1/2 to see if it meets all of the simplification steps. No negative exponents? Nope. 1/2 doesn't even have an exponent. No fractional exponents in the denominator? Nope. No exponents at all. Not a complex fraction? No. And the index of any remaining radical? Well, there are no radicals, so there's no index to even worry about. So that one passes the test. Let's look at this one. We had simplified this one, 1/3. That's the same deal as 1/2. No negative exponents, no radicals in the denominator. It passes all of the tests. Then we had this one. Okay. In every case that we did this one, we got 8. Okay, we had shown 3 different methods. You always got 8. Once again, does it pass the test? 8 is actually a very simple number. I think everybody would know once you got down to 8 that it is 1, but 8 has no negative exponents, no fractional exponents in the denominator. It's not a complex fraction, and there is no radical to even think about. And let's check another one. Let's see. Now I know you might be thinking, wow, why do we have to look back at all these? But I want to look back at all these so that you can be more sure if you've completed it or not. Here, x squared. Let's run x squared through the tests. X squared is the final answer because X squared has no negative exponents. X squared has no fractional exponents in the denominator. X squared is not a complex fraction, and there is no radical. It's just an exponent. Okay, so we got that one. This one with the C that we took a look at. We had to take quite a road to get that one taken care of. This one that you started out with had a problem. Its problem was that it had a fraction in the exponent. But we kept going until there's no fraction in the exponent. The index is the smallest possible number. You have to get those fractions out of the denominator. So c to the 2/5 over c, even though it doesn't look simple, there's no negative exponents, no fractional exponents in the denominator. It's not a fraction over a fraction. We're not talking about exponents here. I'm talking about a whole fraction. And the index was a 5, and that was the least possible one. Okay. Let's go through, check another one. Here we go. This one. We could have even stopped here. This would be a right answer. This is another form of the right answer. Because once again, there's no fractional exponents in the denominator. The index is as small as possible. Okay, it passes all of those tests. No negative exponents, nothing like that. And we kept on going down. And finally, that last one we did. Ooh, okay, lots of things on there. It doesn't look very simple, but does it pass the test? No negative exponents. Check. I don't see a negative exponent. No fractional exponents in the denominator. Check. No fractional exponents. Not a complex fraction. Now, it might look complex to you, but it's not what the definition of a complex fraction is. Okay, so check on that one. The index is the least possible number. Well, we simplified this because we couldn't just leave that square root of that, so that reduced the index. So that one's taken care of. Yep, the index is the least possible number. So that's how we go with that one. Now your job is going to be to work on the assignment. You probably have about 10 minutes left in the period. If for whatever reason you need to go back at this point and look at a part of this explanation again, you feel free to rewind it at this point. Feel free to look at yesterday's lesson at this point. But the idea is that you're to be working on the assignment, not talking to each other. You're supposed to be making sure that you accomplish that assignment for Monday. Also, make sure that if you have any questions, you ask me on Monday. Tuesday, you're supposed to have a quiz on sections 5, 6, and 7. That's what our schedule is. Quiz on sections 5, 6, and 7 on Tuesday. So you need to make sure that you do this assignment very carefully. You need to make sure that if you had any questions on the assignments before, that you ask them. And we will have a very good review on Monday. Have a very blessed weekend.